everyone, my name is Dr. S. Pavan Kumar Reddy, Assistant Professor in the Department of Artificial Intelligence and Data Science, B.V. Raju Institute of Technology, Narsapur campus. I teach the subject is data structures using Python. In that subject, today we'll discuss about the applications. What are the applications are available in that queues concept? Today we'll discuss about the first application is round robin algorithm. What is mean by round robin algorithm means the round robin algorithm is a CPU scheduling algorithm. CPU scheduling algorithm. Here where each process is assigned fixed time slot in a cycle way. Basically, the round robin algorithm is a preventive version. Preventive version means one process is executed in the CPU, the another process are waiting. After completing P1, the P2 will be ready to the executing. After P2 is completed, it is ready to executing the P3. That means it can be follow the first come, first serve CPU scheduling algorithm. Here, the round robin CPU algorithm generally focus on time sharing technique. Time sharing technique. Here, the period of time for the process or job allocated to run the primitive method. The primitive method is called as a quantum. Primitive method, the time is called as quantum time. Here, each process or job to present in the ready queue, that means assign the CPU for the time quantum. In the execution of the process is completed during that time, the process will be end. Else, the process will be go back to waiting table. It is waiting for the next turn to the completion of the execution. This is the round robin algorithm. After that, there is some important observations in the round robin algorithm. What are the different observations means? CPU means central processing unit. AT is called as arrival time. PT is called as bus time. WT is called as waiting time. TAT is called as turnaround time. FIFO is called as first in, first out. TQ is a time quantum. These are the different observations while calculating the to solve the problems. Okay. During the solving the problems, have to find out the waiting time, average waiting time, turnaround time, average turnaround time. These four we have to solve this time during these equations. Okay. See this one. Coming to the example to how to work round robin algorithm by using this some example. In this example, there is a 6 processes are there. The processes are called as P1, P2, P3, P4, P5, P6. This is what P1, P2, P3, P4, P5, P6. Okay, that is named. Here now in the exam point of view, the every problem having given the some arrival time, some bus time. That can be given to the table format. Now, every problem having the time quantum of this system having giving the 4 units. To execute the particular process using 4 units. To complete this task 4 units or before 4 units, no problem. That means every process will completed up to 4 units only. According to this algorithm, we have to maintain 2 tables. First one is ready queue table. Second one is Gantt chart. Okay. Now, the structure of both data structures will be changed after every scheduling. So, the structure of the ready queue and Gantt chart both will be changing for the every time. Whenever to come to the one process is ready to execute the CPU, the structure will be changed. Another time the structure will be also changed. So every time the process will be executing, the structure will also be changed. That is the concept. See this one. We are preparing the two tables. First table is ready queue. Second table is Gantt chart table. Okay. First of all, at the zero time, process P1 is arrives. The process P1 is arrived, which will be scheduled for the time slice is 4 units. Already this is given. The bus time is given for the process P1. Okay. Hence, in the ready queue, there will be only one process. In this algorithm, every time P1 process only executing the CPU. After that, P2 process is executing. After that, P3 is executing. After that, P4. After that, P5. After that, P6. Every time, only one process is executed in the CPU. Okay. The bus time is 5 units. That means P1 is the process, 5 is the bus time. Okay. This is the ready queue. Now, in the Gantt chart, to P1 is executing the CPU. For the there will be given the bus time is 5. The time quantum will be allocating the 4 units. That means this process is completed within 4 minutes, not more than 5. Within 4 minutes only the process is completed. That means P1 is completed 0 to 4. After 4 units, the process P2 is coming to the picture. After that, the P2 process is coming to the picture. Here, meanwhile, the execution of the P1, remaining P2, P3, P4, P5 arrives in the ready queue. The P1 is not completed yet because the remaining 1 unit will be available in the ready queue. The bus time having given the P1, the bus time is given to the P1 is 5 units, but the 5 units, the quantum time is equal to 4 units. The remaining 1 unit is available. This P1 is coming to the picture after completing the P5. So that is P1 is ready to the picture up to 0 to 4 units, no problem. Whenever coming to the picture into the process P2 having the bus time is 6. In this 6, there will be having the only 4 units is available. So 0 to 4, the P2 process is completed into the 4 units, that is 4 plus 4, that is 8. The remaining 2 units will be available. The remaining 2 units after completing the P1, after coming to the completing the P1, the P2 will be coming to the picture. After P1 is completed, the P2 is coming to the picture. Okay. During the process of P2, now the P2 process is executing in the CPU. The remaining P6 is arrived in the ready queue since the P2 has not completed because the P2 has 6 bus time unit, bus time is 6 units. The time quantum is given only 4 units. The remaining 2 units will be available. So it is not completed. P2 will be also added back to the ready queue with the remaining bus time 2 units. So whenever coming to the P3 process is executing the CPU having the process P3 having the 3 units. So 8 P2 is completed 8 units. Whenever to coming to the picture the P3 process 8 plus 3 10 units. So the P3 is completed with the 11 units. So here the P3 process is completed before 4 units. That's why it is not in the next ready queue. Come back to the ready queue. This is the terminated. The execution of the 3 units times is completed. Okay. Here in the ready queue, P3 has completed because there is a bus time is 3, the quantum time is 4. This is the process is completed. It is not coming to the ready back. So it will be terminated, not added to the ready queue. The next process P4. The P4 is coming to the fixture into this picture. That means P4 is executing the process. The P4 having the bus time is 1. So in the Gantt chart, first P1 is completed. P1 is not completed. It is executing. P2 is executing. P3 is executing. The P3 bus time is over. So P3 is not added any ready queue. Now next one is P4. The P4 having the bus time is only 1. So 11 plus 1 equal to 12. That means the P4 process is completed with the 12 units. Next one is the process is ready queue P5. P4 is over. P5. The P5 having the 5 units of the bus time. The time quantum is only 4. Only 4. Since the P4 is completed when it is not added back to the ready queue, the P5 is executed for the whole time slice because the 5 units. That means P4 is completed 12 units. The time quantum is 4. 12 plus 4 equal to 16. The P5 is completed 16. The remaining 1 unit is available because the bus time is 5, the quantum time is 4. 1 unit is available. This 1 unit after completing the next process in the ready queue. See, the P5 is not completed. Previous slide the P5 is not completed because 1 unit is available. That will come back to the next ready queue after P2 process. Here the P1 is ready. P1 is ready to be executing the process. That is P1 is 1 time up to previous. The P5 is completed 16 units. Whenever to coming to the P1 process, 16 plus this 1 time, that is 17. That means the P1 is completed after 17 units. Okay. Here the time quantum is 4. The bus time is remaining bus time is 1. So the P1 is completed. The process is terminated. It is not added to the ready queue. It is not added to the ready queue. See this one. The P1 is completed. Will not add it back to the ready queue. The next process is P4. The P4 has 4 units in the bus time. It will be executed next. The P6 is executed in that next. With bus time is 4. The time quantum equal to 4. No problem. The process P4 is completed within the 4 units. So the P1 process is completed 7 units. Next the P6 is coming to the executing the process 17 plus 4 21 units. Okay. P6 is completed 21 units. So time quantum is 4, bus time is 4. The P1 process is completed within the 4 units. It is not added into the ready queue. Okay. Next, that is the one. Next, coming to the picture, the P2 process is require only 2 units. The 2 units means in the process P2 is completed. P2 process is executing that queue. This one. Okay. We have to see this Gantt chart. P2 will be executed again with 2 units. The P6 is completed 21 units in previously. Whenever coming to the P2 process executing with the bus time is 2 units, the 21 plus 2, that is 23 units. The P2 is completed until 23 units. The remaining P5 is in the ready queue. The P5 is executed till the completion. Now the remaining P5 is coming to the executing the process, that is 23 plus 1, that is 24 units. This is the Gantt chart table with the ready queue. Now we can calculate the turnaround time and waiting time. Here the turnaround time is, the formula is turnaround time equal to completion time minus arrival time. Waiting time equal to turnaround time minus bus time. See this one. The process P1, P2, P3, P4, P5, P6, arrival time is already given in the problem, bus time is already given in the problem, the completion time is, turnaround time will be calculated. How to calculate the completion time means, here What that formula? Completion time minus arrival time. What that completion time is? Completion time minus arrival time. The process P1 is completed. P1 is completed 17 units. Though 17 units minus arrival time. 17 minus 0 equal to 17. Process P1. Okay. Now we can calculate the turnaround time. How to calculate the turnaround time? Turnaround time is completion time minus arrival time. Okay. Turnaround time equal to completion time. Completion time is 17. That is 17 minus 0 equal to 17. Next, you can calculate the waiting time. How to calculate the waiting time? Turnaround time minus burst time. Already you can calculate the turnaround time minus burst time. 17 minus 2. That is 12. The process is completing, the waiting time is 12. Okay. Next process is P2. The arrival time is already given in the problem. Burst time is already given in the problem. Now you can calculate the completion time, turnaround time. How to calculate the completion time means the process P2 is completed 23 units. So the 23 units minus arrival time, that is 22. 23 minus 21, that is 22. Okay. Now you can calculate the waiting time. How to calculate the waiting time? That is turnaround time minus burst time. What the turnaround time? 22 minus what the burst time? 6. That is 16. The process is completed. Process P2 is completed. Next, the process P3. In the P3, arrival time is already given in the problem statement. Burst time is already given in the problem statement. Now we can calculate the completion time, turnaround time and waiting time. Here, completion time. See this one, process P3. Where the process P3 is there? Process P3 here. This process is completed 11 units. That 11 units is called as completion time. 11 units is called as completion time. Now, we can calculate the turnaround time. How to calculate the turnaround time? The completion time minus arrival time. 11 minus 2, 9. 11 minus 2, 9. Now, we can calculate the waiting time. How to calculate the waiting time? Turnaround time minus burst time. What is the turnaround time? 9. Burst time is 1. So, 9 minus 1 is 8. Okay, that is the P4 process. Now coming to the P5 process, arrival time is already given in the problem statement, burst time is already given in the problem statement. We can calculate the completion time, turnaround time and waiting time. Now the completion time is completed. Completion time is for the P5 process is, see this P5 process. P5 process is here, P5 process is here. P5 process is completed 16 units. The remaining time is also executed. The P5 process is completed 24 units. 24 units, that is the P5 process completion time. 24. P5 process completion time is 24. Now we can calculate the turnaround time. How to calculate the turnaround time? Completion time minus arrival time. That is 24 minus 4. The turnaround time is coming. The turnaround time is calculated. Now, after calculating the turnaround time, we can calculate the waiting time. What is the waiting time? Turnaround time minus burst time. What is the turnaround time? 20. Burst time is 5. 20 minus 5 equal to 15. Okay. Now, the process P6 is completed at what units? P6. Remember this one. P6 process. See in this table, the P6 process is there. The P6 process completed 21 units. 21 units, that is the P6 is completed with 21 units. 21 units. Now, can calculate the turnaround time. That means 21 minus 6. 21 minus 6, that is 15. Next, you can calculate the waiting time. The 15 minus The 15 minus 4, that is 11. Okay. Overall, we are calculating the average waiting time, turnaround time. That is 12 plus 16 plus 6 plus 8 plus 15 plus 11 by 6 process, total 11.833 units. Turnaround time is calculated. Already turnaround time is there. 17, 22, 9, 17, 22, 9, 9, 20, 15 by 6, 15.33. This is the algorithm for round robin algorithm. In that algorithm, we are calculating the completion time, turnaround time, and also waiting time. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.